Hello everyone, my name is Aliya and I am a machine learning engineer. In this video, I want to present you my recent project, the full stack on-premise MLOps system for computer vision. One command, one config from Jupyter Notebook to serve millions of users. Now before we start, I want to inform you that this video is only overview introduction, which I want to keep it short and precise just to provide what this project is and what it does. There are a lot of components involved in this project, and if I have to go through all of them, it's gonna take a lot longer. So in case you're interested in, be sure to check the link down below, which I have made another video to explain everything about this project in a lot more detail. And also the link to the GitHub is also in the description. I have put everything in the README on the GitHub page, so be sure to check it out. So without further ado, let's get started. The main goal of this project is to equip you with everything you need in a machine learning lifecycle, especially for computer vision, from a workspace into a production level services. And you know what is the best part? The best part is it takes only one config and one command to run the whole system, from building the models to the deployment. Now, if you scroll down on the GitHub page, you're gonna see this diagram. This is the main software diagram of this project. And you can see right away on the top left that we have Docker here, meaning that our components here are Dockerized and containerized. So basically, Docker is the only requirement you need to start this repo. So I want to do so by going into a terminal, start the project, and let it running, and meanwhile I can explain on other things later. So after I have let's say I have cloned the repo, so I get into the root directory, and then what I need is only docker compose up like this, or you can add deflag here to detach the window. And then what I need is to go to my workspace, which is located on the default port of the Jupyter, which is 888884 times. And by default, the password is 129. You don't need to remember or note down anything here. I have put all the detail into the GitHub page. You can check it out anytime. You can cd into the workspace, and then I want to activate my working environment here, and this is by default it's named computer-dl here. And here comes the juicy part. This is where the one command and one config come from. So all the steps I have carried on so far, you can consider that as a setup step. And now here comes the main part. So I can call python run _flow.py, and it's require one argument, which is configs, and then I have to point into where my config is stored, which is configs, and then full flow config.yaml here, and then just click enter, and that's it. So if I take a look into my workspace here on the left side, you can see, so I have the Python file here, which I ran, and I had a config stored in here. So this is where what the command means. So now, meanwhile waiting my model to build, to train, evaluate, and then deploy, so I'm gonna explain you the diagram and walk you through how each component work together. Okay, let's get to the main diagram here. I want to zoom in a bit. Oh, actually, I want to open it in the draw.io here, because I can click and you can see more clearly where I am pointing to. So we have the big chunk here in the diagram, which is in the rounded rectangle dotted. So this is where your code supposed to be run, and it is in the Jupyter notebooks, or in fact it is Jupyter Lab, the newer version. And this is the main workspace that you can use to run any script And by default, as you saw previously, it comes with a pre-installed conda environment, and you can use that. And in fact, that environment contains all the package that you need for this repo here. Now, when you start the run flow, it's gonna read the dataset that we have stored on the disk here, and as I'm pointing. And this dataset is also versioned by a tool named DBC, which is the data versioning tool. By the way, I have all the link to the main page of each tool in my GitHub page, so that you can check it out. So when I start the main flow, it's gonna read the dataset here, and dataset gonna flow into another tool called DeepCheck. Basically, it's just a Python library that's used to validate the data, and I can show you the result after when we finish the flow run. Then this data, after it got validated, it's gonna pass into our main execution pipeline, which is start from building the models and data loader here, and it's gonna start the training, and then when it's training finished, it's gonna evaluate the model, it's gonna export to another format in a TensorFlow one, which is can be served in the production. And this same dataset also pass into another script, which is to build the reference data for our drift detection method, which I'm gonna show you again later. And you can see that we have prefix above here, which is the orchestration tools, which is orchestrates and automate every step here in the Jupyter. And the down here, you can see the ML flow here as a experiment tracking and artifact loggings. And both prefix and ML flow, their data are gonna be stored in this database, the PostgreSQL here. After our model is finished training, finished testing, then it's gonna be stored into another storage, which is just this storage again, just another location, which I call this model storage here. So it leads to the next point, which is the deployment part. Then we have our deep learning service here, startup and running, ready to use. And this service is gonna fetch the model from our sentence model storage that we have stored the model, the trained model 1 and 2. And then it's gonna fetch the model there, and then it's gonna load into this service. So it's gonna be ready to serve. You can see there's a lot of tools components needed here. So first we use the Fast API as our main tool to build the web service for our deep learning models with deep learning service. And we have a Jupyter here as an ASCII server to serve the Fast API application. And on top of that, we also have the G-Unicorn as a process manager here to provide another layer of load balancing. And on top of G-Unicorn, we have Nginx running here to serve it as reverse proxy. And we also have a simple web UI to demo our models, how it works, how it can be used. This web UI is just a plain Fast API with all the interface built in HTML, CSS, and a bit of JavaScript. And you can notice here I have written a small text here, plus getCam heatmap visualization, meaning that I also include some visualization function in the application, which uses the techniques called getCam. So I can show you later on when our model is finished training. And this is where we're gonna post our request into. We can put the image into, pass into the web UI, and then it's gonna pass into our deep learning service and gonna return the result to the interface. So that's the deployment part. And then down below here, you can see there is another guy here. It's not the user, but it is the prefect worker which serve the automation purpose. Oh, I forgot to mention that for each request that comes to the service, the results and the prediction result and the API logs are saved into the PostgreSQL, and then this prefect worker gonna fetch those prediction and related data that is required, and then it's gonna automate and schedule the model monitoring task, the drift detection. And the tool to monitor our model and detect the data drift is evidently UI, which is very brilliant tool. I have fallen in love when I'm working with this project. And top right mode here, we have the tool to monitor our service and our whole system, our machine, which I use Grafana and Prometheus here. And that covers pretty much everything. So now let's get back to the process that we started. And it seems like it's still training the model. So let's sit back and chill for the time being, and we're gonna come back when it's done. Okay, now everything is done and our model is already on the delivering service up and running at scale. So you can go into the prefix, which is our main orchestration tool, to see how is everything. So we first take a look into our flow, and our flow is named flow here. Take a look. Okay, so it's comprised of 3 subflows, which are train flow, eval flow, and then deploy flow. And as the name is train the model, evaluate the model, and then deploy the model. So let's take a look at the training task, what is in there. So if I come to here, I click training. Basically, it's build the model and then start the training. Before I start the training, we also check the version and validate the version data with the tool, the DVC and deep check as shown. So let's check the results at the output. So if you go to, if you navigate to the artifact here, you can see there is a markdown one, the link to the training task on the email flow. If I click that, and then you got the link here, it will bring you to the training experiment on the email flow. And inside here, you can see there's our artifacts here. First thing is this file, the HTML file. This is the output from deep checks that is validate our training, validating and testing data. And you can click, so everything is fine, so that is nothing didn't pass. And for the pass thing, you can check out. So basically it tries to validate many aspects of dataset, whether there is label drift, and there is an explanation explained here. You can check it out. I won't waste my time going into that because you can read it yourself here. And besides that, it's also save the what I call model metadata, which is contain everything important detail about the model, the class name, the classification layer names, and the input size. And this file is later going to be used in the serving model to automate things. And so these 3 are our output model, the train model, and then two of them are for drift detection. You can read the detail about drift detection in the GitHub page again. So in training task, of course, we have the accuracy, the loss. You can click and see the graph here. Since I want the model to be very small, so I can start up and finish during the code time. So the model is pretty bad actually. As you can see, just for the serve the demo purpose. And after the training is done, so it's gonna pass this model into the eval task back then. If I come back here and click the eval task here, it load that model, and then it also have its own task of evaluation. If I click in here again, it's navigate to another ML flow, and again we have the test metric, point 5 AUC. We have the classification output here as a report, show precision, recall, effort score, and then confidence metric, save here. And after it's done evaluating, it's gonna put our model into a deep learning service, and I'm gonna show you how it's worked now. So let's go into the port 4243, and you got the web UI here, the plain basic one. It looks stupid, I know. I'm pretty bad at HTML and CSS thing, but it just perfectly fine for the demo purpose. Like, so now your model is ready to serve. You can click the box here and select the image that you want to predict with your model. I have images prepared here, and let's pick one, maybe this butterfly. And after you select it, you got the upload image here. When your image is displayed here, click the make a prediction here button. And I didn't implement the loading again, so you might take some time to finish. Okay, and it's now done, and it shows the top 3 classes and the probabilities here. So it's 97% butterfly. I have a button here to trigger on off the heat map, the cam heat map, and I can drag it up to see where the model is looking at in the image to say it's a butterfly. The purpose of cam is to provide insight into what the model thinks, how they come up with the precision. The area that they have the strong highlight, meaning that those areas contribute the most into the output prediction. And as you can see here, the strongest point is not really the butterfly, but it's on the flower that the butterfly is on. Okay, let's try another images. I would say the model gonna fail this time. Trust me. Click the upload here, click the make a prediction there again, and it's predict the cow as a dog, as said. And you can see that it didn't look at the cow. I mean, it look at the black cow, most of the black cow things. And that's because our model is trained only for 5 epochs, and the image size is only 50 pixels wide and height. And one thing, you can notice that the top here is your model name, which is the one that you name in the model metadata. So I can convince you that this is the newly trained model, not the one that I prepared earlier. But you can change the model at any time, because you can just push any model from your storage into production in just single command, and I can show you here. I have a model prepared for the demo purpose, which is work a lot better than the one that got trained here. Inside the test script here, I have one called test API here, and I'm gonna just call this cell. This is the model name that I trained in prior, and I want to use it as a demo purpose because it's a lot more accurate, so we can see more elegant results. And that's it. So if you can see, I just call the put method here, and then it return the update model successfully. And I want you to focus on this text here too. So first I want to reset everything. I can click a button on top corner here, and then I can select an image again. This time let's do the same old cow. Now click make a prediction. Now you see what? The model name has changed, and now it's predict as a cow, so it's correct now. So if I look at the heat map, and it's really looking at the face and the body of cow, so yeah, that's a lot better. Let's try a few more images. So just for the fun purpose, you know, why not? And make a prediction again. Since this dataset is quite easy, and So the model is performed very perfectly in most of the case I have tried. At here, got very strong highlight in the correct place. And just one more, maybe I guess achieve here. Okay, upload image, then make a prediction, and then again almost 100% cheap. And yeah, that is it worked perfectly. Let's get to the last part, which is our model monitoring tool, which is Prefect Worker here, Evidently, and Grafana. But before we can detect the dip, we have to obtain some prediction from the real user, right? And in that case, I have prepared a script just for the testing purpose. I have a script here, which is located in the notebook folder and the loader repo here. And what I am about to do is I'm gonna post 500 noise images into the system, and so we can, oops, I forgot to run this cell. Okay. Then later we can compute the drift, and we expect it to detect the drift, like because our model is trained on the dataset that contain animals images, and then it saw the noise images we support not to be in the training or testing, so it caused the drift. I don't have enough time to go into the detail of what is their drift detection, but you can search Google and see what it is. And by the way, I forgot to mention that the demo dataset here is the one named animals 10 for the Kaggle, which is contain the 10 classes of animal, like contain dog, cat, horse, whatever. Yeah, I gotta put the link in the GitHub page, of course, you can check it out. So now it's posting, and meanwhile it's posting, one thing is that we save all the prediction into our database, right? And then later gonna fetch this output to calculate the drift. You can take a look into what is in the database by going to this pgadmin as at this port, and this is the email, and the password is super secure pw here. Again, I provide all the details on the password username in the GitHub. Then this is Postgres. Okay, I have here, and if I do some quick query, so let's select star from prediction, which is where I store everything here. I got a lot loads in here because I have done a lot of testing and other stuff during the development. It contains the important detail, like I have the model name, it has the input images, which is in the base 64 encoded string. And the important thing is that we store these columns, which is named fees here, which is the feature vectors representing input images, and then later we're gonna use this feature vector to compute those drift detection things. And I also have another place where I store the log or the API, which is also contain the primary key of the prediction table as a foreign key in here, and it's stored like request method where it's come from, and then what is the output that we put to the request. And yeah, it's finished. So the way to trigger the deployment, the drift detection, by default is you navigate into the deployment section on the Prefect UI. You're gonna see one deployment named drift detection evidently, and if you click into that, it is scheduled to run weekly, aka once a week, and you can see then the date here. So it's 11 and then 18 and then yeah, +7, and it keep going on. But you can trigger the run manually by clicking the run button here. I want to click custom run, and this is the default value that it got set. So first, the name is not quite correct because it's based on the last model that it got trained. So it's our latest model, but the current one that we currently demoing using it is this one. So I can copy the name here and paste it here, and you can ask for the date, the number of days, and n, basically the low in the database and the last day. So by default it's 7, so you can pick all the prediction, the last 500 prediction within the past week, and then calculate the data drift. Okay, so I'm gonna paste. I'm gonna use only one here, and the 500 because I have just inject 500 noise images, and that's it. That's set up, and I can click submit, and it can start a flow which is doing all the data drift calculating stuff. So I can click here to see the current task running. Okay, and it's making a progress here. So this is another task that it can doing. Generally it's gonna stuck at here because it is do some mathematical computation for computing the reports and test suits that how evidently call. So we have to wait for a minute, and then we can come back and see the result on the evidently UI. Now it's done, and since prefix couldn't store other type of artifacts apart from the markdown, so I have logged the report ID and test ID here. So the way you see the result, you have to go to the evidently UI, which is on the port 8000. Let's go to port 8000 and click into the project here. So this is the main dashboard. It is written informative enough, so you should go into the report here and test suite. There is no name in here, so there is only the ID, and what you can do is to remember the ID yourself. So you can see the report is E36, so it's this one, the topmost. Sometimes the sorting didn't work that well. Sometimes the latest one go into the lower to the lowest low, but sometimes it's uppermost here, so it's fine. You can click the view, and you can see all the stuff that okay, it's data drift detected. I employ a lot of methods to showcase how you can use different methods into data drift detection, but in fact you can use only some of them, only one or two metrics. It depends on your use case, and most of the time it is experimental. You have to do a lot of research and try and figure out which metric work the best for you. Let's see the test suite, which is more easier to do at, I would say. So test suite is here, the topmost one. So you can see there are in total 8 cases, and then 5 of them fail. Fail means that data drift is detected, and there are 2 of them that not related to data drift detection, but it's quite useful to check the validation in the prediction. Basically it check that okay, if we got the same input, we're gonna get the same output every time, and it also do that in our training set. So it's good to have here for the first 2 tests, even it's not related to the data drift detection. And down below here there is about data drift detection, and you can see only one of them is not detected. So this, as I say, is experimental. You have to validate a lot of things to see, but you can see that most of the metrics show that we got data drift, and of course we got because we just injected the noise images, which is not in a training set. And that is cover the whole system, except I have forgot the Grafana, which is on the port 3000. Let me show you very quickly. And then the default password username is admin. Okay, I forgot to paste here. Oops. Oh, okay. Never mind. Forget me on that. Click in dashboards, and then we have 2 dashboards here, which is the one that monitor the CPU usage, the memory, the cache, whatever, and you can see it's for all the service that we have in the containers. Right. Okay, just last 5 minutes, just like this. And we got another one from the main computer itself. So it's RAM uses, it's CPU uses, and whatever, blah blah, a lot of things here. And yeah, that cover pretty much everything in the projects. I hope you found this project helpful, and if you like the project, please go into the GitHub page and then give it a star, give this video a thumbs up, and share this video with your friends. And thanks a lot for watching.